everyone. Okay, so I'm seeing a typo in this one, and I feel too lazy about going back to fix it right now, so I'm just going to fix it right here. I definitely meant to have a 1 minus y squared. In fact, I even might make that a little more interesting. Let's make it 9 minus y squared. I think that's more like what I want. I don't know what I was doing when I typed it. Okay, so if I'm going to solve this, I'm going to go ahead, a root 9 minus y squared, and then dx, and move that dx over. Okay, one thing in particular I was thinking here was that a out in front, I want to say that as soon as you're told that this is dy dx, you know that y is your function and x is your variable, and you should treat any random stuff that's thrown in the mix like a or b or c or whatever as a constant. So we have some unknown constant that we're just going to keep in the mix. Okay, so to separate fully, I need to divide by the square root of 9 minus y squared. And I get a dx. Okay, so let's go ahead and integrate both sides. And the left-hand side looks a lot like it's going to be related to arcsine. And there are ways other than trig substitution to get there, but I'm going to go ahead and do a trig substitution. It's not very hard to do on this one. It's a pretty clean one. And again, I just want to remind you that you can use any of your techniques, and that's actually one of the things I want to see in these last couple sections is just you continue practicing all those techniques and trying to spot when you need them. So if we're going to do a trig substitution, I'm going to say y equals sine of theta. So dy, oh, and I'm even going to be good and do a correct one and make it 3 sine theta. So dy is 3 cosine theta d theta, which means I have the integral of square root of 9 minus 9 sine squared theta on the bottom, and I have dy is a 3 cosine theta d theta on the top. On the other side, remember that a is just a constant, so its antiderivative is going to be ax plus c. So that side's really easy for us. As I work my way down here, remember this, you would factor out the 9, you'd get 1 minus sine squared theta, and that would become 9 cosine squared theta. So this turns into 3 cosine theta d theta. And when you take the square root of 9 cosine squared, you get another 3, oops, not squared anymore, cosine theta d theta. So this actually becomes really simple as well. We have the integral of d theta equals ax plus c. Okay, and the integral of d theta is theta. So we have survived all of our integration, but we're not quite done. We need to go back to our substitution here and say, okay, well, y over 3 is equal to sine theta, so theta must equal inverse sine of y over 3. All right. So there is the arcsine that we suspected. Like I said, you can do some funny substitutions to just try and get a y in the mix there, or a 9 in the mix with the y squared, but I actually don't mind doing the trig sub on that. I think it's pretty quick and painless. If I want to solve for y, to get rid of an inverse sine, I would have to take sine of both sides. See? And then I need to multiply by 3. And I'm done. And notice again, the C is going to tell us something about horizontal shift in this case, not vertical shift. So if you looked at slope fields, you should see sine waves with amplitude 3 that are being shifted left or right. And also this A would have to be known before you could say anything specific, because that's going to determine your period. All right, thanks for watching.